going to pick up where we left off yesterday. I can get my cell phone to stay up, that is. And we're going to do 3 graphs today. Today, we're going to do one that, if I had been teaching Algebra 1, which would be where I would end the year, with just a very basic one. And now we've done this. I know this is craziness. This is difficult to get done, but this is called the square root function. And we know that square roots can open up, they can open down, they can open left and up and left and down, but this is called the parent, that is the baby, and the baby is simply the one that's in simplest form with nothing added to it. We add all the features. You know that in all of these graphs, the 2 that were up here and the 1 that's here, and even the oblique line, if you put a coefficient that's negative, it has things that happen to it. Now, what's really cool about this function is it's almost got the answers that the parabola and the absolute value have, but not exactly. So the domain is restricted, and x is greater than or equal to 0. Or you could use this notation, your interval notation. And the range is the same thing on this baby again, or you could use your interval notation with the closed bracket. Now, it has a minimum, yes, but this minimum also has a special name. It's called the endpoint. And the minimum point or endpoint 0, 0. The min is actually 0 and it occurs at 0. Now, what's true about this function is that this is an increasing function, and it increases when we say x is greater than 0 or 0 to positive infinity. You'll also have people, remember we talked about this in class, where this is an equal to and this is a closed bracket. It's the fight in the community. Now, as x heads to positive infinity, what did we learn about this one is that it increases, that is rises, and we put in the word slowly, because that's what it does. It's very slow, and we say without bound. Now, x cannot approach negative infinity, but as x approaches 0, and we would say, and I'm going to do something cute that we're going to learn. I'm going to put a little plus up here, and you all don't need to know this bottom one. It's okay. But as x approaches 0, and this little plus just indicates, oh, that I'm coming in from the right side rather than the left side, I'm going to do what? I'm going to fall quickly to 0. Now, that's not true in behavior. It's just that since this has an endpoint, what we see is that as I move this way, I'm falling quickly right there to go to my endpoint. Like I said, this is what I want you to know, is that we just talk about it, that it increases slowly without bound, and it does have a beginning. It says a beginning, it has no end. So what do we know that a square root function is? It's really array. Okay. And so now then we come into the cubic function, and the cubic function takes us back to a lot of things that go on when we had our linear function, only it's a curve, and now y doesn't equal x, y equals x cubed. The domain and the range are the reals, or we can write it negative infinity to positive infinity. And the function is always going to be increasing. Or you could say, like I said earlier, oh, when is it increasing? Negative infinity to positive infinity. There are no minima. And what happens as x approaches negative infinity? What happens here? We find out that the graph falls quickly, or just falls without bound. And as I approach positive infinity, it rises quickly, or just rises without bound. And notice this is, since this is the parent, the baby, this is a positive 1. We know if I put a 10 here, it rises more quickly. If I put a negative 10, it changes directions on things. But this is just the basic function. So we have one more that we're going to do in this grouping. And what we're going to do in this grouping is the cube root function. Now, when I look at my cube root function, it's going to mimic everything that we did in our cube function. All right, except for the quickly part is going to be slowly. And the function, of course, can be written this way. You could also write it in exponential form. So that's y is equal to the cube root of x. What's the domain and the range? It's going to be the reals. Or I could say negative infinity to positive infinity. You need to get used to seeing these kinds of notations. We teachers like to write this because it's just fast. Okay, what do we know? This function is always increasing. Or what could I say? Instead of saying that, I could choose to write it's increasing when negative infinity to positive infinity. There is no endpoint. As I approach negative infinity, what's the difference? This one falls slowly without bound. Or I could say y's approaching negative infinity. As I just said y, okay, so that's did myself in when I said that. And now x is approaching positive infinity, or x increases without bound. Remember, we told you this means we can always substitute without bound when you see infinity. So this one rises slowly without bound. Or you could say rises slowly approaching positive infinity. Again, without bound simply means infinity. So x is decreasing without bound. This is x is increasing without bound. This could say decreasing, y is decreasing slowly without bound, going to positive, negative infinity, going to positive infinity. Okay, so much for video number 2.